Alright, we're trying to find the molarity of a sodium chloride solution that has 2.39 moles of a solute dissolved in 23.3 milliliter solution. So first we have to figure out what we're solving for, and it says determine the molarity. You can usually figure out what you're trying to find in the first half of the problem because it'll tell you right away determine or find or how many. So we're going to determine the molarity. So our solution is M equals N over L. Molarity, this is moles, and this is the liters, or the amount that you have, the amount of moles you have in the liters, and the molarity equals the amount of moles in the liter, or the liter per mole, or mole per liter. So we have a molarity is we were trying to find, so our moles is 2.39 over a 23.3 milliliter solution, but milliliters is very sensitive because this is liters, so you have to convert milliliters into liters before you can go on with the problem. So what we're going to do is 23 milliliters. This is converting, so we're going to convert milliliters into liters, and you always put what you're canceling out on the bottom. And we're trying to turn it to liters, and whatever one's bigger gets the 1. So the liters is going to be bigger than milliliters because there is more milliliters in 1 mole than there is liters in milliliters. So you're going to put 1,000 on the bottom, and then when these cancel out, you're going to get 0.0233 liters. So with this, you're going to put it right down there because now that is liters. And then you're going to basically solve for this problem to get your molarity. So this one was easy because we didn't have to change it to grams. We didn't have to find grams to plug into moles or liters or molarity. So basically your answer is going to be whatever you get out of dividing these two, which is 102.58 molarity. So that's your molarity since we determined it, because we didn't have to use sodium chloride because you usually just use that to find the grams, or you find how much sodium is, how much chloride is, and then you add those together to put into grams, and then you would find grams, how many moles are in the grams to find moles. But you don't have to worry about that because we just had to find molarity, so this one was a simple problem. The next problem is going to be, if I have 90 milliliters or 90 milliliters of a 6.0 mole HCl solution, how many milliliters can I make of a 2.0 milliliter solution of HCl? So what you want to do is basically see how many numbers you have. You have a lot of numbers in here compared to the last problem because you only had 2, but now you have 3. So this could be a diluting solution, or a diluting problem. So this is what you always want to just start with just in case. M1, B1, M2, B2. So for your M1, which is molarity, they gave us 6.0 M. So just plug that in right there. For your volume one, it was 90 milliliters. And then they're saying how many milliliters, which is fine, you can put milliliters in here, it's not case sensitive like the last one. But how many milliliters can I make of a 2.0 molarity? So they're asking for volume, and they're giving you the second molarity of a solution of HCl. So this one is pretty simple. You're gonna keep these two together and then these two together on each side of the equal sign. So you're gonna put the volume here and the molarity right here on this side of the equal sign. And then you're going to put X here and the 2.0 here. So what you get on this side is 2.0X. On the other side, you get 540. So now you're just basically going to solve this like an algebraic expression. And you're going to put you're going to divide 2.0X over to the 540. And so what you get from there is 270 milliliters. And you don't have to convert this to liters or anything because that's what they're asking for. That's what it is. You would convert it because it would be a smaller number, because anytime you convert milliliters to liters, it would become a smaller problem, because there's, like I said, more milliliters in a liter than there are liters in a milliliter. So then, after that, we are going to go to another diluting problem, which might be a little trickier. So, you're given, if I have a 750 milliliters of a 0.50 molarity sodium chloride solution uncovered on a windowsill and 150 milliliters of a solvent evaporates, what will the new concentration of a sodium chloride solution be? So, this is another diluting problem. So, it has a lot more words and it makes you confused. So, you're going to put M1, V1, M2, V2. Because basically they're just confusing with all the words, and if you simplify it and put it in to less numbers, it'll be way easier. So we're looking for what the new concentration will be, which is moles. So we're going to put 750 in the volume, because that's the first number we're given right here. So we can cross that off because we put in the volume. And then we're given a 0.50 molarity, so that goes right there with the mole. Sodium chloride, we don't need that right now. Solution uncovered on a windowsill, so they're saying evaporation, diluting, or the solution changing. And so you're going to put 150 milliliters in the other volume, but the other problem we had earlier, we had to solve for the volume, but it's going to be very close and similar to what we did last time, because you're just using the X. And so this is X, because you're looking for the molarity or the concentration. So with this, you're going to put 750 on the outside, because volume goes on the outside, equals 150 X. So 150 X equals 750.50. So if you put that in your calculator, 750 times 0.50 is 375. You're going to divide this again, because this is the X and you're just trying to cancel it out. So we're going to do 375 divided by 150X, and your X is equal to 2.5. So this happens to be your molarity, what you were solving for. So after it's left uncovered on a windowsill at 150 of a solvent evaporates, the concentration of the new solution of sodium chloride after being uncovered on a windowsill will be 2.5. So then that is diluting. They use a lot of words, but if you're ever given two numbers, just more than two numbers, more than two volumes, or more than two molarities, and they're telling you to find something other than, if they're giving you two volumes and one molarity, then you have to solve for the other molarity. Or if they're telling you these two and they're asking you what the starting was, you just plug it in here. So don't ever get too confused with that. But sometimes it can be confusing to just convert. So what you want to do is you want to, whatever you're given, so if say you're given milliliters right here, you're given, how many milliliters? Let's say 100 milliliters right there. And you need to change it to liters. So whatever you're solving, whatever you have right here, you got to put right there, because you're trying to cancel those out. So let's put milliliters right here, and we're trying to get to liters. So what you want to do is you want to put 1 liter, because liter will always be bigger than this, and then how many of the milliliter is in 1 liter, and that's 1,000. So after you do that, whatever you get on the outside, so you're going to put in your calculator 100 times 1 divided by 1,000 is 0.1. 0.1 liters. And that is how many liters are in 100 milliliters, because it's very case sensitive. This is the solution, or this is the equation to try to find molarity or liters or moles. But this, you cannot put this in this. This is a no. It has to be liters equals liters or else it won't go. And then moles, this is moles, and this is molarity. So you want to be careful there, because if you put milliliters in the liters, it will not give you the right answer because this is very case sensitive. So this is basically converting whatever you want to put right here, whatever you have right there, this is what has to be right there, because these would be canceling out. If you're trying to find grams, those have to cancel out. If you're trying to find grams or you're trying to find moles, you would put grams right here because grams are going to cancel out. You're going to put 1 mole here, and then you would find the grams by, so as you see sodium chloride down here, you would have to find the molar or the mass of it. So you would find sodium on the periodic table, chloride on the periodic table, add them up, put them in the gram slot. Whatever grams you're given here, these two are going to cancel out. You're going to get how many moles are in that many grams. You always just want to put the number down here to convert. So if you want to change to grams, then you need to have moles cancel out to get grams. If you're trying to find moles, you need to put grams together to cancel out moles. If you're trying to find liters or milliliters from liters, you need to put milliliter and milliliter next to each other and leave liters up there by itself. So you always just want to make sure the bottom one and the one that you're trying to cancel out is always diagonally from each other, and then the one that you're trying to find is on the top, because that's what we're going to solve for in the end. But other than that, you're pretty set.